Okay. All right. So I think we'll just get started. Uh, Roger's going to start by asking, I think he's going to ask people what we saw of the eclipse. Several of us here in Rochester went to a very nice lookout up the road where there were all kinds of people out with their cameras and telescopes aimed where we best guessed the sun was. But of course, we couldn't see the sun. There was so much cloud cover. The one thing about being in the direct path of the eclipse, which I found exciting, was that when the eclipse was full, it was completely dark. And that was very exciting, but it was hard to capture on our cell phones unless you did it with a manual setting because the phone brightens everything. So you could not get a video that showed how dark it was. But I was listening to commentators on television about the eclipse and why there's so much excitement for this particular eclipse. And one person said that he thought a lot of people were considered, it was on their bucket list or they wanted to see it during their lifetime. Now, I would ask, why are people considering what they want to do during their lifetime? And I would say that anyone who's halfway conscious about what's going on in the world has to realize we are just marching inch by inch to a confrontation with Russia in particular, maybe China, not caused by Putin, but caused by the insanity of our government, the British, NATO, from which there would be no return. And one aspect of this, which is extremely dangerous and I think should be alarming, as people know, I was interviewed by Colonel Douglas Macgregor a couple of weeks ago, and we were talking about, and I think he chose to interview me, whereas he had wanted to have nothing to do with me 2 years ago, although he was very polite. He said, yes, thank you very much. Good luck. Not at this time. We're not going to be in contact. Why is he in touch with me now? I think because of the French announcement. He has a lot of connections in the French military and retired generals. The LaRouche movement has a lot of connections with French retired generals. I had met some of them in Paris. We're having things falling here. Not an earthquake. And as everyone knows, Macron has suddenly developed a Napoleon complex or something. He wants to send at least 2,000 troops to Ukraine. I asked Macgregor what he thought about that. Was this for real? What is it? And Macgregor said, yeah, probably. According to Macgregor, it's commonly known that Putin is going to take Odessa and that Macron would be sending the French troops to Odessa, where they would frankly be obliterated. The Russians have been very clear that if there are French troops in Ukraine, they are going to kill them. And when I was discussing this with Scott Ritter, he said, look, suppose France sends 2,000 troops, the Russians target that group and they kill 800 of them. Then you have 1,200 French troops. Do you withdraw them, which requires air cover? Do you send reinforcements, which requires air cover? Suddenly, at least France is at war with Russia, and does that bring in all of NATO? Now, in Germany, someone in the AfD, Alternative für Deutschland party, sent a message to their researcher saying, can Article 5 be invoked if a NATO member goes rogue? Like, suppose all of NATO is not together sending ground troops, but the French send ground troops. Does that mean that Germany has to get involved if Russia kills the French troops? And the German so-called expert concluded no, Germany wouldn't be involved. But as you may know, Macron was over in Lithuania and some other places. They're trying to get a bunch of troops. Ukraine has no troops left. There are entire towns and villages who have no men. And Lindsey Graham, our genius, US Senator, one of my inspirations, not to be like him, but inspiring me to run for US Senate. So you get a voice of reason in there. People may remember Lindsey Graham saying, oh, the war with Russia, it's cheap for us, right? All the Ukrainians are dying. They're the ones shedding the blood. It's cheap for us to have this war. We have people arriving. Then Lindsey Graham just said, yeah. And hold on a second. Here's our Houston crew are just getting here. John Jamber has arrived. Hi, John. We have a whole live Zoom audience, so I'm not going to stop everything to say, but I'm saying hello. All right. At any rate, so you have this one very dangerous trajectory with Macron, who also is saying things about other parts of the world. There's 3 people in that group. We have one more coming. Anyway, so that's one scenario with the French, which is extremely dangerous. We have the situation with Israel, Palestine, Israel, Gaza. I read a report today that some Israeli muckety-muck just said point blank that the reason why Israel struck the Iranian consulate in Damascus, which is the same thing as launching a strike on Iran, it's Iranian property, is because Israel wants Iran to enter the war, because Israel wants a pretext to destroy the Iranian nuclear capabilities, which are very, very far underground. And the person who sent me this said that Iran's nuclear program is so far underground that it's questionable whether the United States actually would be capable of destroying it. I can't speak on that. That's not my area of expertise. I do think that it's probably why we've chosen to go to war with the Houthis in Yemen, because it's small. We can starve them, although we're not even doing very well at stopping them from hitting ships passing through that very narrow area between the Horn of Africa and the Arabian Peninsula. At any rate, so there's various multiple ways where we could be headed for annihilation. And I think that's what really anguishes the world. I think that's why people were profoundly moved by the eclipse. And you hear people saying, oh, it brings unity. Well, yes, in a way, because when you reflect, everyone's probably seen the photographs and images of the Earth as seen from lunar orbit. Everybody who looks back at the Earth sees this little tiny blue marble, and they're overwhelmed with emotion at realizing how tiny this planet is in the scheme of the universe. And given how tiny it is, why is mankind at war with itself? And also, I would add, as I said in a Facebook statement earlier today, we might consider, we're here on our planet now, but what we know from the way that stars age and the universe develops, in a few billion years, it is likely the sun will expand unless we figure out a way to feed the sun or something to keep that from happening and swallow up our planet. And that will be the end of everything unless we have figured out how to get off of here, how to get to other solar systems, how to get to other galaxies. Can living beings travel faster than the speed of light? I don't know. I think these are questions that mankind would be better off working on than trying to figure out how we might best annihilate somebody that we don't like. And once we figure out how to explore the universe, we can send people we don't like really far away. We don't have to be near each other. People can build cities in distant planets and distant galaxies. So I think that the usefulness of this eclipse is that it hopefully will get everyone on the planet to reflect that there are bigger forces, bigger powers which are affecting us. And if we actually want to survive as a species in the long term, then it would avail us to try and learn more about the principles by which our universe functions. And I will also add our planet as well, because I think it is the case that we know almost as little about the Earth as we know about the solar system, in terms of we've only recently discovered microscopic living creatures deep, deep within the darkest depths of the oceans. There's just enormous amounts even about our Earth that we don't know. So if we had a sane society that was committed to scientific progress, young people, children from an early age would be obsessed with what they can learn that we don't know, instead of being obsessed with misery imposed on them by a sick political class and a sick financial elite class. So I'm going to leave it at that, and I'm going to introduce my official campaign astronomer. Suzanne said there are not many campaigns that have astronomers. I don't know if there's any campaign, and not an astrologer. He's not going to be telling us our future based on our zodiac signs, but astronomer. So Roger, please take it away.
All right, thank you, Diane. Obviously, there is a perfectly legitimate question to say, what does a solar eclipse have to do with stopping the danger of nuclear war? And Bob, if you could put up the picture of Earthrise, Diane was referencing this, that every person who has been into space, whether it's on the space shuttle, going around the moon, anything like that, has really marveled at the fact that the Earth, there are no boundaries, there are no religious divisions, there is nothing. It is a single unified planet. And this has had a very profound effect on how they thought about the kind of petty problems that seem to dominate life here on the Earth. And I think we saw that today. We went to, just in the neighborhood here, there were maybe a couple hundred people that were gathered, and everybody just gets excited about the idea of participating in something as rare and unique as a total eclipse. Now, we didn't have the greatest observation point. It was completely cloudy. We do have some people here who drove all the way up from Texas to help work on Diane's campaign, to help put her on the ballot. And they were able to stop in Niagara Falls on the way here. And so I just wanted to both to ask them to briefly describe what they experienced. When we were here, we could not see the sun, so we couldn't see the corona, the sun's atmosphere, when the moon was blocking the surface of the sun, but it got dark. It very suddenly got very dark, and almost the whole horizon looked like a sunset. And within seconds, I would say, of the ending of totality, it got bright very quickly. So that was pretty dramatic, and you definitely had you could visualize in your mind the arrangement of the planets that brought this event about. So anyway, I would just like some comments.
Welcome, Joe. Welcome, Houston. Houston is in the house.
First of all, I have the proof right here. And it was, I'm Joe Jennings, just drove up from Texas, and Betty and John came with me. And yes, we went to Niagara Falls, and there were thousands.
Oh.
On both sides, Canada and the US. And we actually had about 5 seconds where the sun peeked through, not when it was full, complete 100% obscurity, but just maybe 4 or 5 seconds afterwards where you got a little sliver, and, standing ovation. Woo! So it was really delightful. It was really delightful.
Multiple languages.
In multiple languages. So yes, Roger is correct. It is really exciting to get a glimpse into eternity, and we got a little piece of it today. Thank you.
Anybody else have any comments about their experience?
Yeah.
Was not the presidential candidate? Is he a presidential candidate?
No,
No, I thought it was for a minute. I heard Joe Jensen.
Oh, not Jeff.
Joe Jennings.
Oh, okay. But I'll tell you, when I was in East Rochester, it was cloudy. Didn't see anything.
Yes.
Hard to believe, isn't it?
Okay. Did I hear someone
Yes,
over
Leni.
Zoom?
Leni.
Yes.
Yes, because I learned that there'll be 90% eclipse down here. So I tried to make a pinhole thing because I didn't have any glasses. And I went outside, and it began to get more and more the shadow from your body became more and more fuzzy. And I couldn't look at the sun. So I tried this pinhole thing, and it didn't function. But then the neighbors came out, and they had plenty of glasses, and people are walking in the street, and we shared the glasses, and we could see, at one point it looked like it was total. The birds stopped chirping, and but it was 90%. And then it took quite a while, and then we could begin to see the crescent on the other side, which was and then it went fast, and the birds started chirping again. So the whole neighborhood around here was pretty excited.
All right. That's good. Bob, if you could go to the next slide. We have a few slides about the eclipse itself. And then I want to get more into the significance of these kind of alignments in terms of the development of astronomy.
I don't want to say him, but
What do we do about that?
all under.
Madeline, can you unmute?
Yeah, it's actually Art.
Okay.
Madeline and I were out in Staten Island organizing for Diane's here. And I had a pair of glasses, 2 pairs of glasses, but right at the point when it was becoming the maximum, when the sun looked like a crescent moon, there was a number of people who came by, including the postal workers, and they were, looking at through their glasses. A couple of ladies came by, and we shared our glasses with them, and they were totally amazed. One of them said, "Wow, so this is what they're talking about. This is what it's all about." Anyway, so that was quite fun.
Yeah, they described this as the Great North American Eclipse because something like 30 million people were going to be directly in the path of totality. And the partial eclipse that some people have been describing, that covered virtually all of the continental United States. So people were able to see at least part of that whole process. Okay, so you want to go ahead, Bob? I want to see some of the next slides quickly. This is a depiction of a Hindu god that ate the sun during an eclipse. In China, apparently, the story goes that a dragon ate the sun, and they would go out and bang drums and make a lot of noise to chase the dragon away so that the sun could return. So eclipses have had a profound effect. Herodotus talks about how a war was ended because the two warring sides, when they saw eclipse, they basically said, we better knock this off. Somebody's getting angry up there. So the next slide. Okay, so I had, well, it's important to try to visualize what's happening. That there's a very specific geometry that has to occur to make this possible. And there's no other planet in our solar system that experiences a total eclipse. And the reason for that, and it may be very rare amongst solar systems in general, is that the moon is, well, let me put it the other way around. The sun is 400 times further away from the Earth than the moon is, but it's also 400 times larger in diameter, so that the disk of the moon and the disk of the sun in the sky are roughly the same size. And that can vary because they're all moving in non-uniform. They are not moving in circular orbits, so the distance of the moon from the Earth changes. The distance of the Earth from the sun changes. And the moon, the orbit of the moon around the Earth is actually tilted about 5 degrees. So that most of the time when the moon comes in between the Earth and the sun, it's either too low or too high to cast its shadow onto the surface of the Earth. And as you can see, this is probably even exaggerated. The size of that shadow on the Earth is very small. When it went past us, it was about 110 miles across. And the moon is roughly 250,000 miles away, and the sun about 93 million. So the next slide. Oh, and just by the way, this is okay. This tiny point that actually reaches the surface, that's called the umbra. And the area that is shaded light gray on either side, that's the penumbra, and that's what's responsible for the partial eclipse. So that's much wider. And then, of course, you can also have a lunar eclipse where it's the Earth that's in between the sun and the moon, and that can block out what would otherwise be a full moon, right? Because it is facing the sun, that it's the light from the sun is blocked out, and the only light that reaches it is the light that gets diffracted going through the Earth's atmosphere along this circumference of the Earth. And that's what often gives it that reddish hue like a sunset.
Christopher Columbus's life was saved by his anticipating a lunar eclipse. They were gonna, the natives were gonna kill him. It's in his diary. He says, well, the great dragon is going to come eat the moon if you kill me, right? And then they let him go.
It could come in handy knowing when eclipses are going to occur, whether the timing is obviously a little out of your control, but I've heard similar stories. Next slide, please. Okay, and this was the path of this eclipse. And the reason it follows this curve, any guesses? Why is it shaped like that?
The Earth is curved.
Yeah, the Earth is curved. The Earth is not flat. So it's actually following a straight line over a curved surface. So began well out over the Pacific Ocean. So Mexico is where it was first seen, and Nova Scotia where it ended. Okay, next one. And that was the path here in New York State.
Look at Buffalo. Whoa.
Buffalo and Watertown were exactly on the center. This is the width of the path of totality.
That the umbra? That's
Yeah, that's the umbra. So some of the people on the phone call were roughly down here, where they saw still maybe 90% coverage of the surface of the sun. Okay, next one. Okay, so now I mentioned that the distance of the moon from the Earth changes. So, and the exact alignment will determine what kind of eclipse you can see. This is a partial eclipse that we've talked about. An annular eclipse occurs if the moon is at its greatest distance from the Earth. Its disk will be smaller so that it won't completely cover the surface of the sun. So in the eclipse that we just watched, the total eclipse, the moon was relatively close to the Earth. So its disk in the sky was at a maximum. It completely covered the surface of the sun. And it's at those unique moments when you can see the atmosphere of the sun, where this is not light coming directly from the surface, but from the atmosphere, the corona of the sun. And go ahead to the next slide. Okay, that's another picture showing the corona. And in addition to people just going out with their eclipse glasses or whatever, looking at this, NASA, many researchers were out there waiting for this moment to try to observe the corona in, 100 different wavelengths and with every type of equipment that they could muster, because there are still a lot of things we do not know about the sun. And if you go to the next slide, one of the biggest mysteries is the energy of the sun is produced by fusion of hydrogen atoms, producing helium and release of enormous amounts of energy. At the center of the sun, you can have, tens of millions of degrees in temperature, which gradually decreases as you come outward toward the surface of the sun. The chromosphere, which is what you would consider the visible, it's not exactly a surface as we think of it, but that's sort of the surface where the light is being emitted. That temperature, 10,000, 36,000, the photosphere, 10,000 degrees Fahrenheit, that's hot, but if you then go out to the corona, which we were just looking at, the temperature shoots up to 1-2 million degrees again. And if it's further away from the source of the energy, how could it be hotter by orders of magnitude? So that remains a big question about how the sun actually functions. And it's only in those brief moments of totality that you can really investigate the corona. Otherwise, it's just completely overwhelmed by the light from the sun.
Does the sun rotate itself?
It does, yes. I think I may have this wrong. I think it takes something like 24 days to rotate. I may be wrong about that, but it does rotate. And that And that can be determined if you see sunspots on the surface of the sun, they move across the face of the sun. So the whole body is rotating. Okay, next one, please. Now, there have been a number of very important eclipses. There was one in, I think it was 1868, where the presence of helium was discovered in the atmosphere of the sun, which by, I think, spectroscopic analysis of the atmosphere. And that helped to prove that, in fact, it was fusion that was occurring inside the sun. This is a drawing. It was in 1905, Einstein developed his the special theory of relativity, and 1915 the general theory of relativity. And the 1915 general theory, he talked about the fact that gravity is not the simple attraction of objects one to another, but that in fact space-time is being warped, is being curved by the existence of the mass of large bodies. And so he argued that light, which has no mass, traveling in a straight line, quote unquote, would actually be curved coming around the sun as it passed near the body of the sun, because the space or space-time around the sun was curved. This is why planets can orbit the sun. If you were to drive your car around in a circle, it takes energy. You're in effect accelerating to change the direction of your velocity. But a planet can do that for billions of years without losing any energy, because it's a force-free path. In a sense, it is a straight line around a massive body like the sun. So what Einstein predicted was that the light from stars in the vicinity of the sun would be bent as it passed the sun. And that was 1915. In 1919, they were able to organize an expedition. One went to an island off the coast of West Africa. Another one went to Brazil, where both locations were in the path of totality. And they were able to observe. We know from having made star maps in the past, the relative position of the stars in the heavens. And in this case in particular, there were a number of bright stars in the vicinity of the sun. So they knew where they should appear in the night sky. When the moon blocked out the glare of the sun, many of those stars became visible in the daytime. All right, I was hoping to be able to see a few stars today, and what happened is that, let's say the star is physically at this location. If its light is bent, we see that light coming from this direction. So they actually, the apparent location of the star was shifted outward away from the sun. And it was shifted by precisely the amount that Einstein had predicted. So Einstein, who had generally only been known to physicists before that time, suddenly became an international celebrity. In all the newspapers, there was, I think it was the New York Times, their headline was, "Stars all askew in the heavens." And, you know, this was pretty shocking development. So these are scientific investigations that depend upon these kind of unique alignments. So if you go to the next slide. Okay, now I want to go into a little bit of the history of astronomy, at least in recent times, to really appreciate the significance of some of these alignments. And what I want to throw out to you right now, so you can think about it a little bit, is that certain of these alignments allow for instantaneous space travel. And by that, I don't mean wormholes opening that thrust you onto the other side of the galaxy, no teleportation. But, and I'll answer that later on, but I want you to just think about that idea. So around 150 AD, there was an Egyptian astronomer named Ptolemy who developed what made absolutely perfect sense. We can feel with our senses that the Earth is not moving. We can see any day you go outside, you see the sun comes up, the sun goes down. The moon comes up, the moon goes down. The stars come up, the stars go down. That clearly we are in the center. We are stationary. We would obviously feel it if we were traveling at, thousands of miles an hour.
Right, if you jumped, you wouldn't land in the same place.
That's right. If you jumped up, you'd land in the kitchen, And that from a sense perceptual standpoint, this was clearly true. And to go beyond that, the argument was that there is a completely different universe with different laws in the heavens from here on Earth. Man is corrupted, the ground is dirty, the heavens are pristine. And his theory was essentially you had these crystalline shells that nested one inside the other that allowed the planets to rotate, and the sun and the moon and the stars as well. And that this was perfect circular motion, uniform motion, none of the complications and difficulties of how things seem to operate on the Earth. That theory held sway for 1,400 years. Okay, and that's something to ponder. There aren't many ideas that have dominated society for that length of time. And this fellow, Nicholas Copernicus, conducted what I think rightly can be described as a revolution, but in certain ways, not at all. He argued that the sun was in the center and the Earth and all the planets were revolving around the sun. And it did make certain explanations of motion simpler. But he still held on to this idea of uniform circular motion. And it would be good to have an illustration of this, I guess, but to explain things like, if you look at Venus, there are times or Mars, when you look at the planets, they are clearly bigger than they are at other times. They're brighter. So it's not constant. There's something that changed. And the argument was made that you would have a circle, the center of which was an empty point in space, but that empty point in space, the center of the circle, moved around the sun in a circle. And you can experiment with this. This is called an epicycle, where at certain times that little circle would put you inside the big circle, and other times put you outside the big circle, so that you could create some kind of an oval, some kind of an irregular shape, while still sticking to this idea of uniform circular motion. But all of this was with the intention of how can I predict where something will be? There was no idea. You didn't even ask the question, why? Why did they move this way and not some other way? What makes them move? That was heavenly laws. Maybe it was angels moving the planets. But we, mere mortals, certainly could not know that. This was somehow off limits to human intellect. So in one sense, it was a revolution. But in a more fundamental sense, it still maintained a lot of those bad assumptions. So if you go to the next slide. Okay, now this is a meteor storm from 1833. And while the picture looks rather exaggerated, a lot of the firsthand accounts describe it as the sky was just full of these sparks falling from the sky. And Abraham Lincoln, I think he was 25 years old, he witnessed this. And he was, well, later during the Civil War, during a cabinet meeting, someone asked him if he thought that the Union could survive. And in answering that, he told this story about this meteor shower in 1833. And he said, I was renting a room from this pastor. And in the middle of the night, he comes banging on my door and telling me, Mr. Lincoln, you have to come out and see this. It's the end of the world. And Lincoln later, during the Civil War cabinet meeting, says, well, the world didn't end now and the Union's not going to end now. The world didn't end then and the Union's not going to end today. So, and Frederick Douglass talks about having witnessed this, other people. So it was quite a shock. And one of the things that it does is it shows that the heavens are not unchanging. That you can also have things from out there come down here, so that there is not this impenetrable barrier between, the earth and the heavens. So that and other things, there have been supernovae. There was one that Kepler witnessed in the late 1500s, where essentially a new star was born in the sky. A bright source of light appeared that had not been there, days or weeks beforehand. So the heavens could change. So those were all things that would tend to sort of shake up this whole view of the heavens. And if you go to the next slide. Okay, this is a picture of me a few years ago in Prague in the Czech Republic, next to a statue of two astronomers. There's a Danish astronomer, Tycho Brahe, and a German astronomer, Johannes Kepler. And go to the next one. There's a little better picture of the two of them. Tycho Brahe, he was a Danish nobleman, to make the most accurate measurements of the positions of the planets that had ever been done. And he had fabricated highly accurate instruments, no telescopes. A lot of them were sort of things like this, where you could measure angles. And so for decades, he would go out on the ramparts of the castle and take these highly accurate measurements of the angular positions of the planets in the heavens. He didn't know what to do with that data. He did have his own theory, which I won't go into, but this fellow, Johannes Kepler, he lived from 1571 to 1630. And around 1600, he had the good fortune of coming to work for Brahe, and Brahe died a year later. And so he was able to use all of these observations to develop his own theory. And Kepler is a very unique figure in the history of science, not just astronomy. And if you go to the next picture, that's a portrait of him. Next one, please. Some people may be familiar with this diagram. When he was a young man, he had studied theology initially, but he wound up being assigned to teach mathematics. And he always had this fascination with trying to understand the thoughts of God, to try to understand how the universe was created. And he knew, or his conception of God was that God was good, that the works of God were harmonious, and that there had to be a lawfulness about them. Now, what this represents, if people are familiar with the term the Platonic solids, there are only 5 figures that can be created in 3-dimensional space, where each of the faces, like a cube, all of the sides are the same and all of the angles are the same. So there are only 5 such figures that can be created. And one might ask, well, why only 5? Why these 5? And whether the relationships that exist between these figures. And so he initially made an attempt to represent the diameters of the different orbits of the planets by placing these Platonic figures inside shells, inside spheres. These were circular, and then putting another shell inside that and placing a cube, then a tetrahedron, etc. And it worked pretty well. It wasn't perfect, but it was an initial attempt to find the order in the planets, that they can't be arbitrary. They're not just floating around out there. There had to have been a sort of a grand plan. So if you go to the next slide. During the course of his work in the early 1600s, he began to expand this idea both of harmony and proportion to directly look for musical harmonies. And you may have heard this term, the harmony of the spheres, which just kind of gets thrown around. But what he was able to show, if you looked at these would be angular velocities. How many degrees does Mercury sweep out in a day? That he could assign values of that angular velocity during the course of the planet's motion. And he found that they fit almost perfectly with the musical scale. And he spent a great deal of time really elaborating this and essentially constructing the musical scales, not only major and minor, but of various modes, and using that to show that that, in fact, is what governed the planets. And I can remember years ago, this is probably 1970, the University of Buffalo, where I was going to school, I found this record in the library where they had taken these tones and you had to adjust them for octaves because the outer planets are obviously going extremely slowly in their orbit. Mercury's going much faster. And so they adjusted all the octaves and they had a record where they were playing all of the musical intervals for all of the planets that Kepler had developed, 400 years before. Okay, next one.
We have a piano.
If you want to, sure.
You have to go back to that slide.
Okay, Bob, go back one. Okay. Diane's gonna play a few planets for you.
I'll play it, tell me what planet it is. Here's one.
Okay, so that, I think that was Earth.
Yep,
Okay,
let's see here. Oh, so I should move it. I don't think Adam is really in that octave.
no, well, they were in different octaves, but he corrected for
Status. And then Jupiter.
Jupiter.
Sounds like Jupiter.
Yeah.
Is that because the orbit is so elliptical that it's?
Yeah, yeah, it's very eccentric.
I must see Mars.
No, that was
Mercury.
that was Mercury, yeah,
Where is Mars?
right here, yeah.
Oh, Mars.
Did you get the flat in there?
Yeah.
Okay.
Otherwise would have been.
So not only were these individual orbits harmonious in the way that you just heard, but if you took adjacent orbits, you would get harmonies between them, much like creating a musical composition where you have different lines being played against each other that hopefully also sound harmonious. So this seems strange from the idea of how a scientist would try to investigate the physical world. But remember, he's trying to understand the thoughts of God. How would God have created it? Would it have been arbitrary? Would they have been billiard balls bouncing off each other in the heavens? Or would there have been this kind of inherent harmony and beauty? So that was one of the tools that he used to take this data set that he got from Foucault and to turn that into a theory of the whole heavens. Now, the next slide, which I just showed you, he developed this idea and proved that, in fact, the planets travel in ellipses, that they're not circular motion, and that there are the areas swept out in this month when it's closer to the sun is going to be equal to the area swept out in that month when it's further away. But to appreciate this, I want you to take a moment and just think about this. Kepler had destroyed the idea of uniform circular motion. He had, taken the idea of Copernicus that in fact the sun was the center. So now the Earth is moving. Now, who's ever been, probably as a kid to a carnival where they had these whirling teacups? You have four people and they're spinning around, and that's spinning around something else, and that's spinning around something else. And you try to look out at the trees or the people or anything else and try to explain their motion when you're moving. This was the problem that Kepler had created. Things were so much simpler when the Earth was stationary and everything just went around us. And you could say, yeah, I see it up there. Well, what if, and between today and next month, it'll move from there to there. Well, what if in that month you move from here to over there? How does that affect your observations? Because all you can do is point in the direction where you see it. You don't know the distance. And your own motion is going to totally distort your own observations. So, and he said, they're not circles. It's not uniform. And at that point, it's really, well, anything is possible now. They could be moving in squares. They could be moving in some completely irregular orbit. It doesn't have to be, you know, an ellipse is a conic section. If you take a cone, if you cut it straight across, you'll get a nice circle. If you cut it at an angle, you'll get an ellipse. But it doesn't have to be an ellipse. He spent enormous amounts of time trying out hypotheses. And one of the things that's wonderful about studying Kepler is he's completely transparent about how he approached these problems. He'll say, well, you know, I tried this and it didn't work. There had been a book called De Magneta, published in 1600 by William Gilbert, which described the Earth as a magnet, the whole planet as being a magnet. And this was a new idea that had sort of hit the market. And Kepler said, well, that sounds like a good idea. There has to be a motive force. There has to be something that moves the planet. It doesn't just move. It's not angels, most likely. What could cause it to move, and what orbit would it cause it to take? So he tried various ideas. We know that magnets can attract or repel each other. So he developed various ideas about the orientation of a planet. If it was a magnet and it had a north pole and a south pole, and maybe the way it rotated at certain points, it would be attracted, so it would be pulled in, and then it would be repelled, so it would be pushed out. He had the idea that the sun itself was emanating some kind of motive force, and almost like magnetic fields or something else, as the sun itself rotated, that it would sweep through the heavens, and that would push the planets, which would also explain why the planets that are further out travel more slowly, because they receive less of that motive force. So he described many of these hypotheses, you know, and he was perfectly happy to say, no, that's not it. You know, let's try something else. Now, the thing that I had said earlier about instantaneous space travel, anybody have any idea how that idea might fit with what I just said about dealing with the problem of a moving observation post, namely the Earth?
Well, we still are observing something with light. I mean, light, the entity, and you're assuming the light is instantaneous there. That maybe.
Yeah, but I'm talking about actual space travel.
Oh, I see.
How could you instantaneously travel in space?
Ride the planet.
Well, certainly you're on a planet traveling in space. But
Well, if things are aligned a certain way, that would make a big difference.
how?
Well, suppose they're lined up with, as opposed to something being totally way off on the opposite side of the sun, it's on the same side as you are, or much
Right.
closer. Clearly moments where the distances are much reduced.
Yes. Yes.
Well, you'd have to take an angular look at what you're observing and write down, you know, when and whether or not it's aligned with other parts of the world.
Right. Well, when you have these alignments, and I'm not talking specifically about an eclipse, but when an eclipse occurred, we saw that the moon was in exactly the same place in the sky as the sun, right? So what does that allow me to do? That means I can go to the moon and know exactly where the sun is from the standpoint of the moon, exactly where the Earth is from the standpoint of the moon. And specifically what Kepler had to do regarding this question of, he had to determine Earth's orbit, right? Because if whatever changes in Earth's orbit, that's going to screw up every other observation. So how can he observe Earth's orbit? He would have to go to Mars so that he could look back on Earth. Now, specifically what he did in that case, he knew from these decades of observations that Mars had a regular orbit. I think it's 686 days and a fraction. So he was able to determine that every 686 days, Mars was going to be in the same place in its orbit. So he was able to glean from these massive tables of observations a grand total of 7 observations of where Mars was at that precise location, and was able to use that to essentially look back and say, where was the Earth when Mars was in this fixed point in the heavens? And a lot of these alignments are like that, where you can gather information by putting yourself mentally on that other planet, on that other observation post. And so it was from that kind of effort that he was able to determine what Earth's orbit was, to make corrections. You have to constantly make corrections on all of the observations that you had been making. What happened?
I don't know. I guess they're still watching. They probably aren't seeing this. Yeah, it's just my phone.
Oh, okay.
Hmm.
Okay, so can you go to the next slide?
I'm just wondering, maybe this is too complicated. If you don't know what the Earth's orbit is yet, how do you figure out how long the Mars's orbit is? Because how do you know when Mars returns to the same place? That seems tricky to me.
Yes. And I don't think I can give you a more accurate explanation of exactly how he did that. But that is what he did. So I'll have to leave it at that. And the thing that when we started out talking about what our senses showed us about the heavens, that Kepler has, there's this wonderful quote: for the thinker who grasps the causes of things in his mind before they appear to the senses, stands nearer to the creative truth than those who only begin to consider things after they have seen them with their eyes. So it's often what you cannot see which is most important. And Kepler, starting from the standpoint that there has to be a physical cause, it not only led to what's always described as Kepler's 3 laws of planetary motion. He never treated them as laws. If you read his writings, he never said law number 1, planets move in ellipses. He did not give great importance to that, and in fact, he realized that since it could take any path, it took an enormous amount of work to be able to prove to himself that in fact it was an ellipse. It wasn't something that was sort of the next obvious choice, and we'll see if that seems to work. He had to prove that for himself. So he had this much higher standpoint of both what he was looking for and willing to put in the hard work in order to prove it. Now, I'm not sure what else we've got for slides. Okay, well, this is another. Geometry is one and eternal, a reflection out of the mind of God. That mankind shares in it is one reason to call man an image of God. And that also goes with this idea that the laws that govern the earth that we're familiar with also govern the heavens. And that itself is a major breakthrough, because then it means that we can make discoveries, we can conduct experiments, and we can then apply them to places that we can't go yet. But that we know that the principles are going to hold there as well. So have we got any more slides? I think we're about at the end here. I didn't want to read that one. So that's what I've got. If people have questions. Yeah.
I have to say, despite trying to uh pay attention to the whole thing, I have to say it's a good lesson. And I have to say Rochester is home to science and technology, and this is like beautiful.
Well, and I think Kepler is one of the sort of the giants of science, the scientific method, who is really highly underrated. He's often dismissed as some kind of either a mystic. He had these spooky ideas of music in the heavens, but it was a tool of scientific investigation. That whatever is governing the planets is going to have to obey these kind of laws. So he's well worth studying. Yeah.
You can go ahead. Marcel, go ahead. We'll go to Rick and.
I was, given the very perilous global situation, nationally, internationally, and so forth, this idea of isolating or making observations in the universe through senses, but then figuring out what's really going on aside from what our senses tell us, and being able to prove these things, and therefore making discoveries. What does, say, breakthroughs in something like astronomy that you had given this wonderful lesson on, what does that have to do with solving the problems and ameliorating the crises that we're currently facing on the planet?
Well, one of the things we talk about in terms of the Middle East, they need water. So how do we get water? The Mediterranean is salty, the Dead Sea is salty, the Red Sea is salty. So how do you provide water for all the people of the region? Well, that's the job of science. I mean, we know how that can be done, but let's say we didn't know how to do it. We'd have to figure out how to solve that problem. In terms of producing water for the Middle East, it's more a question of whether there's the political will to implement known economic policies that can solve that problem at least. But that's always been the history of science, is that you think of how the population of the world has been able to increase exponentially. It didn't just happen because people discovered sex. It's because that we established an economic foundation based on an understanding of physical principles that allowed us to grow more food, to produce clean water, to conquer disease, to reduce child deaths. So those are sort of the fruits of those scientific discoveries. And one of the best indicators of a healthy, productive economy is the amount of money that is being put into basic scientific R&D that may not have an immediate return, that isn't generating a profit tomorrow. I mean, that's one of the critical roles that NASA has always played since the 1960s, where it wasn't trying to produce something for profit. It was simply trying to explore the world and discover things, and in the process have generated thousands of spin-off technologies that have created whole industries. The electronics industry, integrated circuitry, telecommunications, biomedical, sensory devices, all those things that came out of the space program were byproducts of much more fundamental scientific investigations. So I think that that's always been true, and that really goes to the question of what has become so sick and degenerate about the economy, the Wall Street, City of London economy, that places little or no value on that, and instead it's all about money, making that by whatever means possible. So that would be my answer. Rick and Lenore?
Yes, we had the privilege of in West Virginia here to have only a partial eclipse, and I call that a privilege because we did this actually 30 years ago in front of the Leesburg office to the exact year. What we did is we made an assumption. We knew the circumference of the Earth because we had done Eratosthenes' experiment. So we figured we would measure the distance to the moon, measure it, because what we did is we say, okay, well, we heard that in Buffalo it was a full eclipse, and we had a partial one, and we took the difference of the angular difference in terms of how much the sun was not covered. And we knew the distance between Buffalo, having driven it many times, and Virginia. So we said, okay, that's the bottom of the triangle. And so now we can go up, and we know that angle up there is that angle down here, the difference. And so we measured the distance to the moon. So that was one thing.
What'd you get? What'd you get as a number?
I think we're about right. I'm not sure. It's a long time ago. So we're more or less right. Because of course you have different bands in there, so you're not exactly in the center of each band. Anyway, the second thing, which is really interesting, which you could have experienced today, we saw it through. We had binoculars projecting onto a piece of white cardboard, so which is different than looking at it, with your eyes through the thing, because you actually learn something very important. So what we found is that we expected, at least 30 years ago, we expected this. We learned something since then. But anyway, we expected the moon to move over the sun nicely, evenly. And then when it was done, it was nice and evenly move off of it. And this, of course, is crazy. But anyway, what can I do? That's what we thought. So as anybody will, like a simple arithmetic thing. But what happened, like today, we saw it upside down, by the way, in terms of because of the binoculars. But what today, the moon, the little crescent was on the left. And then as time went on, it went over the top. That's really the bottom. Which is really the bottom for you. But in any case, so what that told us is what you thought was the Euclidean universe is not. There's something else is going on. There's an interaction, and they're not perfectly merged. So, one's going one way, one's going the other way. So that was a good refutation of our implicit assumption. So that did us a lot of good.
I had exactly the same experience today, Rick, because I thought, okay, it's just going to move over, and then you have to get the little crescent on the other side. No, it moved to the bottom, and then it moved over to the right. And it's a very good lesson concerning sense perception and all this stuff.
Yep.
Were you able to track the moon?
Yes.
Good.
Yeah.
So that's it from West Virginia.
Okay,
I like to ask this question. Honestly, that presentation of the sun and the moon and all that stuff. Obviously today, as people are talking about, I know this may sound like crazy what I'm about to ask, but you know, the DI, the race baiting and all those irrelevant stuff that's being taught today, all over the place by some agendas.
right.
Could you, give your, perspective on what you think about it and, if it's really like, truly scientific, what they're teaching, or if, whether doing goes against the principle of science.
I'm not sure specifically what.
In other words, like, you know, there's a lot of controversy with, there's like, I'll give an example. Someone could say, oh, the moon, like climate change, for example, people are shouting climate change,
Right.
the earth is gonna end. Some will say like, oh, the sun is racist or whatever.
The sun is racist.
Yeah, I never heard that. I never heard that, but you know, they're teaching stuff in the schools and in the universities.
Right,
They're using like narration that
right.
pointed either at like race or climate, like does that make sense with the climate?
I don't know about so much about the question of race, exactly what you're getting at with that, but I definitely think that there is a major problem with the way science is taught, period. And that the intention is to dumb down the population so they will believe whatever they're taught by the relevant authorities, whether that's their professor or the TV or the government official, and where people have little ability to independently judge what they're being told.
So in other words, they're not taught to think for themselves.
Yeah.
They're taught to say whatever they say goes is right.
Yes, and there can be enormous pressure. I mean, we certainly see that around the question of climate change, where there was a brutal campaign waged against any scientist who said, I don't agree, or you're overlooking things like the question of solar output and, you know, how the amount of cosmic rays coming into our atmosphere affects clouds and how that can affect cooling and heating of the earth, that there was a really vicious campaign carried out against those scientists, the idea of climate deniers. It's like people who deny the Holocaust. You're essentially being called a Nazi if you don't accept the idea that man is destroying the earth and we have to shut down our economy and let a few billion people die in order to save Mother Earth. So
That makes sense.
that's one of the most glaring examples currently about what's being done. And
I just had to bring that up.
yeah, well, and one of the reasons that we in the LaRouche organization have studied Kepler, and this was something that Mr. LaRouche really urged us to do for many, many years, is because you have to go to original sources. You have to see what the people who made these great discoveries, how they thought about it. How did they make that discovery? Rather than just saying, that's why I mentioned this thing about the Kepler 3 laws. That's the only thing that most people know about Kepler, and how he figured out an ellipse or how he figured out equal areas and equal times. None of that is known. That's dismissed. It's just like, give me the equation that gives me the answer that I can find in the back of the book. And I don't have to know how the equation was developed, how the process works that way. And so you get a lot of sheep. And that's a major problem. So you often don't have people speaking out, the so-called ordinary citizen saying, well, why do you say that? Prove that. Challenging what they're being told.
It's very interesting because I'll tell you, if you say today, especially in a place like New York, if you say like, oh, the only way we can have a train from Rochester to Niagara Falls in the afternoon is if we privatize the railroad. If you say that, then you're called all kinds of names in the book. You're called a bigot. So that's just an example. So
Yeah.
I can understand, like, if you disagree with something and you're trying to question something that isn't like that needs to take a second look, then you're called a Nazi.
And
Could we get the volume up for suddenly the voice got much less. Could we get
Ooh,
the mic
Rogers?
up a little bit?
well,
No, there
someone-
is no mic.
someone
Can other
speaking from the
people-
audience here.
Can you hear Roger the same way? Hello?
Yeah, it's fine.
Okay, so it's the
maybe it's just
person
me.
asking the
Okay,
question.
sorry. okay.
Okay, good. Okay. Can we?
Yeah.
No, I wanted to sit, but go, Denise has.
No, but it's because he's behind the mic and the phone.
Right, so people who have a question have to come up here. What, John?
I've got a question, a point that you can describe it. Lynn's confrontation with his teacher about Euclid geometry when he saw the steel and the force in the chip.
Yeah. I mean, I think there are lots of examples where, we've all had this experience. You get told something in class, and do you simply accept it because that's sort of the easy way to go, and you'll get the answer right on the test, even if you have no idea why that's the case? Or are you an independent thinker who says, well, I have to educate myself so I actually know what is the correct solution to this problem, and then have the guts to stand up and fight for it, even if you get, attacked for it.
Right.
So,
Yeah, I wanted to.
go ahead.
Just, because we can wrap up the Zoom part, but I don't know, Bob, are you able to pull up the leaflet I wrote for this? Because I don't think we have any copies left here, right? We don't have any. And maybe someone can read that Leibniz quote. Is there one single one? Myself's looking.
Someone must have it on the computer.
It's on the website. I'd like to get it right because it's so beautiful, and it is also actually the point of what it means to be human, what it means to be created in the image and likeness of the creator. Maybe Bob will find it. We don't have any. I think we distributed them all.
I know I saw one on your website, so maybe it is on the website.
Yeah, here we go. Yay. All right. So I can, if you scroll up a little, there we go. All right, stop. Perfect. So Leibniz, and it's the Odyssey, the preface, right? Love is that mental state which makes us take pleasure in the perfections of the object of our love. And there is nothing more perfect than God, nor any greater delight than in him. To love him, it suffices to contemplate his perfections, a thing easy indeed, because we find the ideas of these within ourselves. The perfections of God are those of our souls, but he possesses them in boundless measure. He is an ocean, whereof to us only drops have been granted. There is in us some power, some knowledge, some goodness, but in God they are all in their entirety. Order, proportions, harmony delight us. Painting and music are examples of these. God is all order. He always keeps truth of proportions. He makes universal harmony. All beauty is an effusion of his rays. Now that is so magnificent. But if you think about what your mind and well, I started just thinking about this more. In your mind is a concept of perfection. For example, a simple one. In your mind, you can imagine a perfect circle. We all can. What are the attributes that you could say the circumference is everywhere equidistant from the center? It is also the maximum area for the minimum circumference perfectly. But now try to draw a perfect circle. And whichever one you draw, if the closer you get, there will be some imperfection to it. But also you can think of a flat, a circle or a shape that's really misshapen, like has some problem with it. And maybe you make a discovery as how to make that more perfect. Or you have things that seem to not be congruous, that don't fit together. You have an anomaly, which is how most scientific discoveries are made. You think the world works a certain way, and then there's something that doesn't fit in this image, your mental map, and then you develop an idea which suddenly causes that anomalous piece to fit in. You say, oh, it all comes together. Oh, it's all lining up. And there's a certain kind of joy with that, right? That you make a discovery to some problem that's been really bothering you, and it's resolved, and there's a joy. Or in music, again, I don't mind, Joe, if you don't mind, but you think about how our mind perceives things, like you would say, is this that is a little bit, you wouldn't want to end the piece there, right? But then you say, right, it can go some, there's a way where you say it resolves. That's not because we're all brainwashed in Western, so-called Western classical composition. There's an ordering which exists in our mind. And when we discover ways to make that coherent, then there's a happiness about it. So this idea of self-perfection is a real principle of joy. And you think Christ said, I don't know where, but be ye also perfect as your Father in heaven is perfect. So what is that? That is an ever increasing search for self-perfection, which I think is the happiest thing that human beings do. And that's what's in our Declaration of Independence. It's not Locke, it's not life, liberty, property. It's life, liberty, pursuit of happiness, which is the right to perfection, the right to a process of perfection, which is what really makes people happy. Now, think about our culture today, which says, no, there's no such thing as truth. There's one expression that grates like fingernails on a chalkboard. I hate it. She spoke her truth. Speak your truth. What do you mean it's not the truth. If it's your truth, it is not the truth. True is a principle that you can prove. And if you discover that you are wrong, this is where Lynn used to talk about getting rid of your ego, right? A scientist delights in discovering that they were wrong because it means there is a more perfect understanding of the way the universe works. Now, if we had an educational system that was committed to this process, the children would be very happy because their minds would be encouraged to always search for ways to demonstrate that they were right. And if they discovered they were wrong, they wouldn't have to go to a safe room where they can be protected from the truth, because it's more important that their feelings not be hurt than that they know whether something is true or not. And I think for this reason, for example, this whole this transgender idea is a real assault. If you're telling a human being, if you're telling a child you were born in the wrong body, when every single cell, every single living cell has your DNA in it, and you're saying that this is wrong and you can arbitrarily, God made a mistake and you can arbitrarily decide that you're not that. It's so, but then what else is not true? Well, I can say that, the moon is made of green cheese, and don't tell me that I'm not allowed to have that opinion. Or I can say that, my mother talking too much is causing climate change. And, and therefore I had to murder my mother or whatever. I mean, you see these horrible, horrible things. Whereas if you have an idea that the universe also is in this process of perfection, like you look at the development of the biosphere, which is so incredibly exciting that you have supposedly no life, somehow the great miracle, we don't know what, we still haven't figured out, us genius human beings who think we know everything, how life starts. How does something go from being dead to alive? How does that happen? We don't know. But we know that life is infinitely more powerful than non-life. If you think about the biosphere and its effect on the abiotic, simple things like trees on rocks. Ultimately, what's alive will break down what is dead, will use it for its purposes. And you think about how life developed from little single-celled organisms to developing photosynthesis, to creating an atmosphere, to getting out of the oceans, to how much more advanced a mammal is than a reptile, and then a human being, which is a leap, because it's not merely that our physical body regulates temperature and that we can control our motion. We're not like a jellyfish floating around. We don't have to lie out on a rock to get warm. But it's not just that you can actually make a discovery and dramatically increase your power over nature. So a machine can lift 700 times more, or thousands or millions of times more than a human being. A machine can generate energy. We've invented things that have infinite degrees of power more than we do in our physical selves, right? So that is a natural part of the development of the biosphere and of the universe. And that means knowing that there is a trajectory, knowing, as Leibniz would say, that there is a reason why something is this way and not otherwise, then you can say with authority, this policy is wrong, right? This policy goes against the principle of the perfection of the universe. And this policy is coherent. And you can say, well, I thought this policy was the best policy, right? Coal-powered engines, but then we discovered, maglev trains, or we figured out something that was even more powerful. So you're improving on it. And I think if we could get the idea that this is our identity, as opposed to this arbitrary, it is very much also like Thrasymachus, right? Who is right? Well, whoever is stronger, of course, right? Well, are they right about climate change? You're not going to prove it in a debate. It's just whoever has more money and more publicity, that determines who is right. And the universe is going to have the last laugh because there are just certain things that we cannot go against. One of it, which is what happens when you have a nuclear war. Steve Starr, some people know him. He is a physicist. He was at University of Missouri, and he's an expert on the effects of nuclear weapons. And he writes for the Bulletin of Atomic Scientists. And he told me that the Department of Energy right now is investing a huge amount of money in producing studies that try to debunk the fireball theory. Now, we saw there were fireballs in Hiroshima and Nagasaki. That's what happens. That's the physical principle of a nuclear bomb. That's why when you drop a nuclear bomb that's 15 times more powerful than what we used in Japan, you can map out, as Stephen Starr has done, where the fireball is going to be, how many things are going to be incinerated, how many miles away the oxygen is going to be sucked out of the air to feed this fire. You can know that. The Department of Energy right now is spending millions of dollars to do studies to say this is not true. So what would be the point of that? And we saw it because we laughed about it here last year, the public service announcement from New York City, right? With the lady coming out of her brownstone. Don't ask me how it happened, but the big one has happened. Yes, New York City has been hit by a nuclear bomb.
Oh.
And here she is in front of her brownstone and says, but you can survive a nuclear war. And the first thing you do is go inside. Go inside and turn
the radio.
right and turn on the radio and listen for when it's safe to come out. This is complete insanity, and it's also evil because for our poor younger people who've been through this screwy school system where they don't do physical scientific experiments, where you never have to prove anything. You never have to prove why one thing is this way and not otherwise, and why you're not just, why can't I just have my opinion? We all have opinions, right? No. So for someone who's been through that, oh, well, they say we can win a nuclear war. You know, oh, we could win a nuclear war. We could survive. All I have to do is go inside my brownstone and turn on the radio. And then she said, this almost killing. If you happen to be outside during the blast, when you go inside, make sure to take off your outer garments and put them in the washing machine. I mean, it's crazy. So that's why also I think the work that my campaign is doing, what I've been doing on classical music is so important. Art is so important because in those domains, poetry, people still have a little bit of confidence that they can recognize beauty. Why something is beautiful, why something is ugly. Maybe you don't know why, but you have a very strong sense of when something is ugly and when something is beautiful. And we urgently need that because we have to allow the population to have a sense of truthful principles so that we can get our way out of this mess. And it is a mess and it is very dangerous. And if you have people who think that they can do whatever they want and it won't matter, it is the case that the universe will have, we may destroy our entire planet and nothing will be here, but the principles of the universe will be here. And I just think that would be a very bad thing to do because I like Beethoven in particular, which would be lost. But, you know, I don't know, or is mankind going to have to go through that and a more perfect species will come after us, or I don't know. But I think it were better if we figured out how to avoid this. And that's the point really of the campaigns and jumping through these stupid arbitrary hoops of ballot access and non-debates and hoping that we can reach what Leibniz asserts exists, which is the desire for perfection that's in everybody's soul. That is in every single human being. It's in there. And we just have to find it. So that's a yes.
Yeah, when I was very young and.
You have to come here and talk to them.
Oh,
They can't hear.
Tony Blinken too, this song.
Yeah, if he doesn't recognize it, we'll put him in a mental hospital, someplace where he's protected.
But just that, a comment many years ago when I was very, very, very young woman, and so I was asking, well, how do we organize people? How do we organize students on the college campus? Well, first of all, find out what their major is, and if they're majoring in sociology, don't waste your time. Find the students who are you know, studying physics, math, other fields of science. I said, oh, okay. So, that's what
Roger, I'm wondering, when you think about Kepler's life, right, it seemed like there was nothing in the physical world in which he lived that would confirm what he was developing in the heavens, where you had two sides battling it out to the death, each thinking God was on their side against the other guys. And I think both sides were trying to recruit Kepler in a certain fashion, but I'm wondering if what he discovered in his life, because he died before he could see realized, what would be manifested in his work, except up here, but that the final resolution of that terrestrial conflict created the conditions where his principles could be applied. Could you say anything about that?
Well, I mean, he lived and worked, at least the latter part of his life, during the 30 Years' War in Europe. Joe is referencing when Europe was being torn apart. And depending on which side, whether it was the Protestants, the Catholics, the Calvinists, if a nobleman, who of course ran the town, people worked for him, if he said, okay, we're joining the Catholics this week, you were required to declare that you too were a Catholic, or your property would be confiscated and you would have to leave town. And Kepler moved a number of times because he refused to do that. He held his religious beliefs to be vitally important to his identity. So he was sort of at odds with everybody often at that time. There's also a very famous quote of Kepler saying, I've discovered this, and if it takes 100 years for someone to come along who can understand what I wrote, that's fine by me, because these are eternal truths. Eventually someone will read it. I know it, and that was adequate for what he as an individual could accomplish. So I think, we have to, there's always a question of how do we pay our debt to people of prior generations who have made these discoveries, who have labored tirelessly to build the society that we have. When you think about the standard of living, the life expectancy that we have, the medical discoveries, all of that, we owe that to these people who are generally no longer with us. And the only way that we can repay them is to use our own brief lives to try to make similar contributions that will help future generations that we will never know. So I think that's often the lesson to be taken from whatever travails people had to go through, and the achievements they were able to make in spite of that.
Great. Very good. So we have to sign off, and I want to work with people here on the petitioning details. The Zoom station has to be used, and I have a quiz for people here. So thank you everyone remotely for joining us. I hope all of you are going to help with the petitioning, and we'll see you soon.